Hello everyone and welcome to part 4 of the full calibration guide for a 0.2 nozzle, primarily in order to print miniatures. In the last episode we talked about the temperature and flow ratio, and today we're going to go over the pressure advance, or PA for short. The PA is arguably one of the more elusive settings when it comes to the calibration, and that is in no small part because it is a prime example for the concept of if you did everything right, people won't know that you've done anything at all. It certainly takes a backseat compared to both the flow ratio and the temperature, and while I would agree that it is less impactful than either of those two, I wouldn't go as far as to say that it is optional. But in order to understand why it's important and how we are going to evaluate the calibration, we need to know what it actually does. If the flow ratio regulates how much material can get pushed through the nozzle, then the pressure advance regulates how much of that material is prepared in advance, hence the name pressure advance. Now, this is obviously an extremely simplified version of what PA does and still fairly vague, so I want to show you a little experiment to visualize the effect. Right here I have liquid modeling paste. I usually use it to patch up gaps in 3D prints or miniatures. As you can see, once I open it up, the paste flows freely out of the tube, and once exposed to air, it will slowly dry and harden. In that sense, it is similar to 3D printing, or at the very least as close as I can get without buying a 3D pen. Now, let's say I want to draw a line just from point A to point B. It's pretty simple. It's not exactly perfectly straight, but in terms of thickness, it is a fairly even line. But what happens if I draw another line and this time I slow down or speed up? You may think that this doesn't change much because we're not changing direction, but keep in mind that the modeling paste is leading the tube regardless of how fast or slow I move it, meaning that if I slow down, the modeling paste will accumulate and make the line thicker. This also works the other way around, and if I speed up, then the paste will have less time to flow out of the tube and the line will be thinner. The same concept applies to your FDM printer. Every time the nozzle would slow down, for instance when it's about to reach a corner or starts to print an overhang, you would run into a similar issue, and that is where the pressure advance comes in. Think of it as an additional control valve for the flow ratio. If you can, I would highly recommend trying to recreate the experiment, as it will give you a pretty good understanding of how this problem could affect your prints without having to fully understand the technical knowledge behind it. You don't have to use modeling paste. You could simply use a bottle of water, put some paint into it and a small hole, and if you then move the bottle at different speeds, you should be able to get a similar effect with the droplets. So, how do we calibrate the PA? Like with all of our previous calibration steps, we start in Orca Slicer. We open up a new project, click Calibration, and there we can select our extruder type. If you are not sure which type your machine is using, please make sure to do some research before you select it here. For our calibration method, we want to select the line type. And finally, we come to the settings. And this is where a lot of people struggle when it comes to the 0.2 nozzle. You can select the starting pressure advance, which by default is set to 0, and then you set the end pressure advance, which by default should be a very low value. Last but not least, you select the step value. Now for a 0.4 nozzle, you'd use very low values here. However, if you were to use these values for the 0.2 nozzle, the calibration would be inconclusive and borderline impossible to evaluate. I'll get into why in a second. Instead, what I recommend and what I do is to set the end step to at least 0.5 but no higher than 1, and the PA step to 0.025. Make sure that you check print numbers, and now Orca Slicer will generate the calibration model. Don't worry if you're just seeing PA test in the Prepare tab. If you slice it and look at it in the Preview tab, you will see the actual model. And if you look back to the experiment from earlier, you can probably tell how the calibration is going to work. Each of these different lines will be printed with a different pressure advance, and throughout these lines, the printer will speed up and slow down respectively. Once the print has finished, the idea is to look for the line that has the most even thickness. This, unfortunately, depending on the color of your filament, can be very difficult to spot with the naked eye. I highly recommend that you use a flashlight here to make sure that you're not missing any spots, and if you can, I'd also highly recommend using a magnifying glass. If we had used the low values for a 0.4 nozzle here, then these lines would be virtually identical. Unlike with the flow ratio calibration, we can't give ourselves an advantage here by slightly priming the calibration benchmark, because it will not leave the print plate until we're done. It is extremely delicate and it will be impossible to remove without ripping it apart, so we have no other choice but to evaluate it while it is on the print plate. But there is one trick that we can use to help us out a little bit. To make it easier to record, I have used white filament on a super tech plate. This is just for visual clarity. I actually recommend that you use gray filament on the regular texture plate. You can already see that the lines that have been printed at the higher end of our PA range were so thin that they've broken down and are interrupted. This effect will be even more drastic on the textured plate, which is something that actually works in our favor. If you take a Q-tip or perhaps even a brush with slightly harder bristles and you move carefully, slowly up and down the lines, you might break even more of them because they are so thin. If we go back to the slicer for a second and select in the Preview tab Speed, you can see where exactly the printer will speed up during the calibration. It's around a quarter into the line and then again in the last quarter. That is where you want to pull up and down with your Q-tip. It is crucial that you don't use a glue stick for this calibration. Unlike with the flow ratio plates, where we had to make sure that everything stays on the plate, the PA lines breaking down makes the evaluation a lot easier for us. It's also important that you don't apply a lot of pressure here, because considering just how fragile these lines are, even if they have printed successfully, you might damage the ones that you need. I recommend first examining the lines as closely as you can, and only when you have trouble deciding which line to pick should you try to sort out the imperfect ones with the Q-tip technique. After that, all we have to do is to read the calibration to get the value for our pressure advance. In my case, that is usually around 0.25 to 0.35, and then enter that in our filament settings. Make sure that you actually enable the pressure advance, because it's disabled by default. Much like with the other values that we have calibrated, and even more so if this is your first calibration, I urge you to stick with reasonable values and to observe your first couple of prints and not leave the printer unattended for too long, just to be safe. And that's pretty much it for the pressure advance. In the next part, I will go over the final touches, as well as some other projects I have planned for the future of this channel. With that being said, take care everyone, and have fun printing.
Thank you.